So welcome back, and this time we are looking at the properties of a square. Now if we go back and we just remind ourselves, if we go back and look at this diagram with the set, the square is right in the middle. The square has all the properties of all the other shapes. So let's write them down. Okay, the first thing is that a square has all sides equal. Right. The second thing is that the diagonals, in fact, let's rather do this one next. The second thing is that all the angles are equal. All right, and in fact, all the angles equal 90 degrees. All angles equal 90 degrees. The second thing is that, or the third thing rather, is that the diagonals are equal. All right. Now remember, for a rhombus, the diagonals are not equal. For a rectangle, the diagonals are equal. A square is both a rhombus and a rectangle, so the diagonals are equal. The diagonals bisect one another. That's true of all parallelograms. All right, the diagonals, let's try that again. The diagonals bisect the angles. So we can see we've got like a 90-degree angle here, but the diagonal cuts it into two equal parts of 45 degrees. The diagonals are perpendicular. Perpendicular. All right, and then I'm just trying to see what the last one is. I seem to be... Okay, the last one is opposite sides equal, but we in fact have said all sides are equal, so we don't really need that one. Okay, right, and here is another diagram, right? The only difference between this one and the previous one, it's got all the properties marked onto the shapes. Now, the bad news is that you actually need to learn these things, all right? You need to learn the properties, but it really does help if you can visualize these shapes, all right? So let's just quickly remind ourselves. Here we've got a rhombus, okay? And the special case of a rhombus is a square, right? Here we've got a parallelogram, okay? And we can see all sorts of things about this parallelogram. The opposite sides are equal, the opposite angles are equal, the diagonals are not equal. We can see that as we bend it over, this diagonal is actually getting longer and this other one is getting shorter. But in the special case where we have a rectangle, all rectangles are parallelograms, the diagonals are equal. All right. Okay, so if we can try and understand the set structure, then it becomes easier to learn the properties. Right. Now, what we're going to ask you to do, and we're going to ask you to do this in your own time. The answers are actually given on the next page. It says, see how many different quadrilaterals you can find in these grids. Okay, so for example, here's one. Okay, I have to mess that up completely. All right, let's start again. Okay, so one thing we could do is we could find a big square. All right, we could also find a smaller square. All right, we could also find a shape like this. All right, we've just got to join dots. Okay, what is this shape? It's got one set of parallel lines. All right, this is a trapezium. Okay, so we're going to let you do this in your own time. So, and I realize I'm not sharing the right screen. Okay, in your own time, see how many different ones you can find. Okay. And there are the answers, okay? So there's a whole lot of different shapes that you can find. Notice that trapezium is one of the ones that I found. Okay, all right, there's 3 different squares. See, that square is actually a square, but it's going like that. It's kind of tilted, all right? And there's some different arrowheads. See if you can find them all, okay? Can you find 12 kind of special quadrilaterals and 4 non-special ones? So notice the non-special ones are ones about which there's nothing special, all right? So this one here, there's nothing special, and this one here, there's nothing special, all right? Okay, so now what we're going to do, we're going to leave you to try that in your own time. What we're going to do is we're going to ask you to answer these, true or false. Pause the video, have a go, and then we'll go over them just now. Okay, the diagonals of a parallelogram are equal in length. False. All right, and again, we can see that because as we tilt this parallelogram over, they don't stay equal in length. The diagonals of a rhombus are perpendicular to one another. True. If lines are parallel, then the co-interior angles are supplementary. Are complementary. Unfortunately, that's false. All right. If lines are parallel, the co-interior angles are supplementary, not complementary. Okay, a quadrilateral with opposite sides equal is a parallelogram. That is true. All parallelograms are rhombuses. False. The opposite angles of a parallelogram are equal. True. If two triangles, okay, we haven't got to this yet, so this shouldn't be here. All right. The diagonals of a parallelogram bisect one another. That is true. The diagonals of a rhombus are equal in length. That's false. The diagonals of a parallelogram are perpendicular to one another. False. All squares are parallelograms. True. A rhombus is a special kind of square. False. A square is a special kind of rhombus. The diagonals of a rhombus bisect the angles. True. A parallelogram with a 90-degree angle is a rectangle. True. If I have a quadrilateral with 2 pairs of parallel sides, it must be a rectangle. Not true. It could be a parallelogram. If the diagonals are bisecting, it must be a parallelogram. That is true. If it has equal diagonals, it must be a square. Not true. It could be a rectangle. Rectangles got equal diagonals too, so that's false. If the diagonals bisect the angles, it must be a rhombus. That is true. And if I have 4 identical right-angled triangles, I can make a rhombus. That is true as well. And I'll show you why that's the case, okay? If we've got 4 identical right-angled triangles, let's just draw one. Okay, that's one. And I'm going to draw a kind of another one here, which is going to be identical. All right. And I'm going to draw another one here, which is going to be identical. And lastly, I'm going to draw this kind of blue one in here, also identical. What we get now, these are right-angled triangles. So we've got a right angle here. We've got a right angle here. We've got a right angle here. And we've got a right angle here. But remember that these triangles are identical. So if, for example, this angle here, all right, will actually equal this angle over here. All right. And because those angles are equal, these lines must be parallel because those are alternate angles. All right. And this angle over here, sorry, I don't want to put a cross on that one. I want to put a circle on that one. This little angle over here will be equal to this little angle over here, all right? And then in this blue triangle, all right, and the purple triangle, this, for example, would be equal to a circle and a cross, and this in the blue triangle the cross would be there, making these lines parallel, and the circle would be there. All right, and that will make a rhombus. So if you've got 4 identical right-angled triangles, you can always make a rhombus. Okay, we're going to now dive into our last concept, and that's the idea of congruency and similarity. All right, similar means like, okay, all right, but in maths it actually means it involves proportion. Okay, in English, congruent means identical, okay, and in maths it means identical. So if we look at these pictures, all right, which things are identical? Okay, well, that, and that all look absolutely identical. Okay, all right. If we look at these trees, they're not identical, but they are similar. The one is just an enlargement of the next, okay? All right, they're in the same proportion, and that's what we mean by similarity. Okay, a really important idea is that when we turn something around, that doesn't make it not similar or not congruent. So you'll notice all these pencils are facing different ways, but in fact they are all identical. Any one of these pencils, if you cut it out, you could stick it on top of one of the other ones and it would cover it exactly. All right, that's what congruent means. Congruent means identical. All right, what similar means is in the same proportion. Okay, and notice that the fish is not similar to anything here, and it's not congruent to anything, and nor is the cactus. Okay, now let me ask you this. Does this tree look similar to the other trees? And you might say, yes, it's a tree, but actually it's got a different set of proportions. It's actually differently shaped, and it's not similar. No. Okay, right. Now, we're going to get a bit more mathematical, and we're going to consider these shapes, and we're going to try and work out which ones are similar and which ones are congruent. Now, remember that for them to be similar, the proportions need to be the same. All right. For them to be identical, they need to be exactly the same. All right. But if we look at, and I'm just going to do one example here. If we look at this rectangle here, its long side divided by its short side is 2. If we look at this one here, the long side divided by the short side is 2. These two are similar. Number 4 and number 9 are similar. All right, but they're not similar to number 8. We can actually see number 8 is a little bit more blocky. All right, okay. And so what we want you to do is try and see, are there any that are identical? Okay, identical means congruent. We're going to give you quite a lot of time to look at this. So pause the video, and we're going to ask you to fill in the table on page 107. Well, not the table, but we're going to ask you to, you can work out some calculations here. In other words, you can divide short side by long side, all right, and then you can see which ones you think might be similar and which ones might be congruent. We've left you some space for your calculations, and then some space to fill in here. All right, pause and have a go. Right, so number 6 and number 2 are in fact, number 6, 2 by 3, and number 8. Number 6 and number 8 are identical. They are congruent. All right, let's look at 1 and 5. 1 is 1.5 by 3. And number 5 is 2 by 6. No, it doesn't look identical at all. It doesn't, yeah. So I don't think there are any others that are identical. Only 6 and 8. Now, if we look for ones that are similar, number 1 and number 5, right? So I'm looking at this is twice as long as that's twice as long. 4 and 9. We're looking for rectangles that are twice as long as they are high. 4, 9, and 3 are all similar. 4, 9, and 3. Right? If we look at number 8, so 4, 9, and 3. If we look at number 8, all right, it's 1.5 times as long. Okay. No, there's no others that are 1.5 times as long. 8 and 6 are in fact identical. All right, we've said that already. But if we look at number 7, the long side's 3 times longer than the short side. Same with number 1. 7, 1, and 5 are all similar. All right, 7, 1, and 5 are all similar. All right, and just looking for any others that are congruent. What about number 1 and number 5? And that are similar rather. Number 1 and number 5 are in fact exactly the same. They're 2 centimeters or 20 millimeters. They are not only similar, but they are also congruent. So 1 and 5 are also congruent. Okay. Right, let's formalize this. Okay, 2 shapes are similar if they have the same angles and their corresponding sides are in proportion. The one is just a bigger version of the other or a smaller version. Okay, and the symbol for similarity is that. Okay, 2 shapes are congruent if they're identical, and they can literally be placed on top of one another. And the symbol for congruency is 3 lines going that way. Okay, right, and that brings us to the end of the module. All right, we are going to have one more lesson on this module, which we'll tackle next time, and that's just an extension exercise which ties some algebra to some geometry, which we think you'll enjoy. All right, have a good day, everyone.